Okay, so we're doing our second lesson for scale factor and similarity. And so this is looking at scale diagrams. And so by the end of this, you should be able to convert between different metric units, so millimeters, centimeters, kilometers. And we're going to use those to help us with some conversions. And we're also going to keep on working on how to make a scale factor for two different measurements. Okay, so not necessarily counting squares, but actually looking at measurements. And so some basic conversions that you need to remember. Okay, 1 centimeter is the same as 10 millimeters. 1 meter is the same as 100 centimeters. And 1 kilometer is the same as 1,000 meters. So we're going to use these ratios to help us solve some problems. So the first thing we need to do is we're going to convert some measurements. I'm going to do the first few and you're going to do the last ones on your own. So I'm going to show you the work that I would like to see, and yes, I would like to see this because as we are going to work more and more with units, this method is going to be helpful. So I want you to practice it now on the easier stuff so when we get to the harder stuff it's going to make more sense. Okay, so we need to go from 45 millimeters to centimeters. We want to think about units canceling out. So if you think back to our exponents unit, we said if you had like x cubed over x squared, that's x times x times x over x times x. So we looked for things to cancel out. We're going to do the same, but now we're looking at units instead of a variable. So we have 45 millimeters, and we want to turn it into a measurement in centimeters. And so we need to set up our ratio in such a way that when we multiply it, millimeters cancels out. So the millimeters needs to go on the bottom. So if you look back at the top of your page, it says 1 centimeter is the same as 10 millimeters. So 1 centimeter is the same as 10 millimeters. Okay, so when we do this, the millimeters will cancel out and we'll get left with centimeters on top, and that's the unit that we want. So now we go 45 times 1 divided by 10, and we get 4.5 centimeters. The shortcut way is thinking, okay, well, we need to divide by 10, and so dividing by 10 is like moving the decimal place once to the left. But I do want you getting used to using your decimals.
Please contact the office.
All right, it's after school. We're going to get a few of those. Looking at the second one, now we need to go from meters to kilometers. So again, we're going to set up our ratio in such a way that the meters will cancel out and we get left with kilometers, the unit that we are interested in. So the ratio is 1 kilometer is the same as 1,000 meters. So kilometers goes on top and 1,000 meters goes on the bottom. The units that we don't want cancel and the units that remain are the ones that we're looking for. So we go 3,450 times 1 divided by 1,000. So that's the same as moving the decimal place 3 times to the left. So we get 3.450 or 3.45 kilometers. Okay, we'll do the third one together. 34.6 meters, and we want to turn it to centimeters, and the ratio is 1 meter is the same as 100 centimeters. So we need to times by 100 centimeters over 1 meter, so that way our units cancel out. And now we have 34.6 times 100 divided by 1. So 34.6 times 100, decimal place is going to go twice to the right. We get 3,460 centimeters. Okay, you are going to try those next 3 on your own, and we are going to check those together in class tomorrow. All right, it says the picture below is a scale diagram of grain nemesis longboard. The picture has been reduced using a scale of 1 to 19. What is the length of the board in real life? So the first thing we need to do is we actually need to measure what length we have in our drawing. So you're going to measure from the top to the bottom. And when you measure this on your paper, you should get about 3.8 centimeters. So they have told us that this is a reduction. So that means the measurement should be larger than 3.8 centimeters. So they tell us that the scale is 1 to 19. Okay? And when we measure, we see that it is actually 3.8. Okay, and so in order to keep the ratio equivalent or equal, we need to do the same thing on both sides. So we're going to take our scale factor of 19 and times it by the drawn of 3.8 to tell us what the height or the length of the longboard is, and we get 72.2 centimeters. So that's how long the longboard is in real life. Another way that you could have done this is, the formula we use is scale factor equals drawn for the image over the real. So in that case, we had 1 to 19 as our ratio, and we had drawn of 3.8 centimeters. So again, we need to think of making equivalent fractions. So times the top by 3.8, do the same on the bottom, and we get 72.2 centimeters. So there's a couple different ways we can set this up. Let's look at your next set of examples. Okay, an actual VW Beetle measures 2.8 meters in length. So hopefully you notice that this is a reduction. Okay, the image on your paper is not 2.8 meters long, it is much smaller. So they want to know what is the scale factor. So in order to find the scale factor, we take the drawn measurement divided by the real life measurement. Drawn over real. It goes alphabetical, so it's a nice way to remember it. And so the scale factor is 4.5 centimeters over, well, we need them both in the same units. So we're going to take our 2.8 meters, and 2.8 meters, we need to turn it into centimeters. So we have 100 centimeters in 1 meter. Meters cancel out. 280 centimeters. So 4.5 centimeters over 280 centimeters. And so then our scale factor, we can divide those. Hope you notice that the centimeters cancel out, so scale factor actually has no unit on it. We get 0.016. No units on a scale factor. Your unit should cancel out when you are looking for a scale factor. If they don't cancel out, you have done something wrong. Okay, next one. Stewie and Brian have decided they want to go on a road trip to Edmonton to see West Edmonton Mall. The map they have used uses a scale of 1 to 4,750,000. If the distance between Calgary and Edmonton is 6 centimeters on the map, how far do they have to drive? So, keeping in mind a ratio is drawn to real. So 1 centimeter drawn on the paper is 4,750,000 centimeters in real life, or 1 meter is that many meters in real life. It doesn't matter what units you use, the ratio still stays the same. So in this case, they're telling us that it's in centimeters. So they're saying that this is 6 centimeters. So we want to know what actually is the distance. How far do they have to travel? Well, we know Edmonton is 3 hours away, so that's about 300 kilometers away, so our answer should be close to 300 kilometers. So the way that we do this, figure out what our factor is, and so we've times it by 6, so we need to do the same on the other side. So 4,750,000 times 6 gives us this. centimeters. So 28,500,000 centimeters. We don't measure in centimeters, we measure in kilometers, so we're going to put our units into kilometers. So 28,500,000 centimeters, and we need to turn it into kilometers. So I'm going to go to meters first, and then from meters to kilometers. So in 1 meter, there are 100 centimeters. So now the centimeters are going to cancel out. And then I'm going to need to cancel out the meters to get kilometers. And 1 kilometer is the same as 1,000 meters. And now meters will cancel out, and so the only units that are left are kilometers. So I have 28,500,000 times 1 kilometer over 100 times 1,000. So we're dividing by 1, 2, 3, 4, 5 zeros. That means we're going to cancel out that many place values. So 1, 2, 3, 4, 5. We get 285 kilometers. Just under 300, so about 3 hours traveling. Okay. Last example says the distance from Vancouver to Halifax in real life is 5,790 kilometers. The distance on the map is 14 centimeters. Okay, so 14 centimeters, but this is how many kilometers it actually is. So, according to the map, how many kilometers does 1 centimeter represent? And what was the scale factor used? You're going to try those on your own as well, and we're going to check them tomorrow.